Welcome to this eLearn Security video training lesson on man-in-the-middle attacks. In this video, we will see how we can use several tools in order to perform a man-in-the-middle attack. During the video, we will mainly focus on sniffing credentials sent over HTTP, but the same techniques can be used for other unencrypted protocols like Telnet, FTP, and so on. Man-in-the-middle is a very popular attack and, during the last years, many tools have been written to get the best out of it. Some of the most popular tools to perform a man-in-the-middle attack are EtterCap, BetterCap, MITM, SSL Strip, ARP-Spoof, and Cain-Enable. Although these tools will mount the actual attack, during the video, we will also use tools like Wireshark and DSniff in order to capture and analyze the traffic. The first thing we have to understand before seeing how to run a man-in-the-middle attack is what promiscuous mode is and how it works. Promiscuous mode allows network interface cards to accept and process all packets received, even if they are not intended to them. Normally, when a network interface receives a frame, it drops the frame unless it is addressed to that network interface MAC address, or if it is a broadcast or multicast frame. In promiscuous mode, the card allows all frames through, thus allowing the computer to read frames intended for other machines or network devices. When hubs were used, promiscuous mode allowed hackers to read all the traffic on a network. This was possible due to the fact that hubs are Layer 1 OSI devices, and they forward the packets to every host in the network. When switches replaced hubs, things became more difficult, since switches forward packets only to the correct destination. Let's run Wireshark in order to see what traffic we can see on the network. We will sniff the traffic on our TAP0 interface. As we can see, nothing happens since we are not sending or receiving any packet. The only packets that we may see are service or broadcast packets. Notice that this does not mean that other machines in the network are not sending traffic, we just can't see it. Now that we know what promiscuous mode is, let us start our ARP positioning attack. In order to successfully perform this attack, we first have to enable the IP forwarding. This will make our machine a proxy between the two victims. In other words, we will be able to receive packets and forward them. If we don't enable this option, the connection of the victims will be timed out. This happens because when one of the victims tries to connect to the other, we will capture the request on the way. Therefore, if we don't forward it, we cannot reply with the correct response and thus, the connection will be dropped. Now that we've enabled the IP forwarding, we can start the actual ARP spoofing attack against the two victims. We will make them believe that they are talking to each other, while instead, they will both be communicating with our machine. To do this, we have to constantly send ARP replies to both hosts. Via these ARP replies, we will tell the victim number 1 that the IP of the victim 2 has our MAC address. Thus, whenever victim 1 wants to send a packet to victim 2, it will first send it to us. As you can imagine, we will have to do the same for victim 2. We will be constantly sending ARP replies in order to tell that the IP address of victim 1 has our MAC address. Thus, whenever victim 2 wants to send a packet to victim 1, it will first send it to us. As we said at the beginning of the video, many tools can be used to run this attack. The first one we're going to use is called ARP-Spoof. Let's first display its manual by running ARP-Spoof in the terminal. As we can see, it's very simple to use. We have to specify the interface to use with the -i option. In our case, we'll run the attack on the interface TAP0. Then, we use -t followed by the target IP address to which to send the ARP replies. In this case, we're targeting the victim IP address 10.10.10.15. At the end of the command, we will specify the IP address that we want to impersonate. In other words, we will send ARP replies telling the victim that we are 10.10.10.200. Now, we have to run a similar command in order to send ARP replies to victim number 2. So let's open a new terminal and copy the previous command. This time, we will invert the IP addresses. Now we can run both commands from our terminals, and as we can see, ARP-Spoof starts sending ARP replies to the hosts. If we open Wireshark, we can see all the packets that we're sending. Since we want to intercept the victim communications, we'll filter out all the ARP packets and wait for the victim to send some traffic. After a while, we can see some traffic between the two machines. If we look closely to the transmitted packets, we can see that the victim with IP address 10.10.10.15 has used his credentials over HTTP to access a website hosted on 10.10.10.200. If we want to avoid looking among all the packets for HTTP credentials, we can use the Wireshark filter http.authbasic. As we can see, it will only return the packet where the credentials were used. If we inspect these packets, we can see the credentials sent over the network. Another tool that we can use to obtain the credentials is dsniff. Dsniff is actually a suite of tools that include passive, active sniffers, and MITM tools, and can be used as a password sniffer for several protocols like Telnet, HTTP, FTP, SMTP, POP, and more. While the man-in-the-middle attack is running, we just need to run dsniff on the correct interface and wait for the results. So let's run dsniff with the -I option, followed by the interface we'd like to use. Now that it's running, we have to wait for the victim to use its credentials. After a couple seconds, we can see some HTTP credentials in the output. The next tool we will use to mount the same attack is EtterCap. EtterCap is one of the most popular tools designed to perform man-in-the-middle attacks, and it comes with both graphical and command line interface. Let's open a terminal tab and execute EtterCap on graphical interface. We do this by running EtterCap, followed by the -G option. The first thing to do once EtterCap runs is to select the type of sniffing and the relative interface. To do this, let us click on Sniff and select Unified Sniffing. Now we have to select the interface on which we'd like to sniff and run the attack. We'll use the same interface used before, so let's select Tab 0 from the drop-down menu and click OK. As we can see from the list on top, now we have more options. What we have to do now is specify the hosts we'd like to attack. Keep in mind that EtterCap will perform the attack for us, and at the same time it will sniff the network and capture the packets, so we don't need any other tool. In order to specify the targets, let's first click on Hosts, and then Scan for Hosts. This will scan for the available hosts in the network. After a few seconds, the scan ends and we can see the list of hosts by opening the host list view. Similar to the attack run before, we'll select the two hosts 10.10.10.15 and 10.10.10.200. So let's click on the first one and click on Add to Target 1. Now, let's select the second victim and click on Add to Target 2. With these settings, we are telling EtterCap to run the attack between these two hosts. Notice that we can add as many hosts as we want in the target list, but for now, we'll focus only on these two. Now we can start the attack. To do this, let's click on MITM, choose ARP Poisoning, and then enable the Sniff Remote Connections option. We're ready to go. Let's click on OK to start the attack. We can now go to View and then Connections in order to see the captured packets. After a while, we can see from the bottom panel some HTTP credentials found. We don't have to look through all the captured packets to find these credentials. EtterCap will automatically find and prompt them by using its built-in filters. The last tool we'll examine is called BetterCap. BetterCap is another popular tool used to conduct several types of man-in-the-middle attacks. Like EtterCap, it can perform an ARP spoof and sniff the connections at the same time. Before using it, let's see its help manual. To do this, we go to Terminal and run BetterCap with the -H option. As we can see, it offers a very big list of commands and options. In our scenario, we will use BetterCap with some basic commands. We will use -I to specify the interface to use. We will also use -X to enable the sniffing mode. After these two, we have to specify the targets of our attack. Although BetterCap is able to automatically detect the gateway in the network, but since we're not going to target the gateway itself, we will use the -G option to set the first target and then the -T to specify the second target. Notice that we are not setting any specific protocol. Therefore, BetterCap will sniff and parse all the default ones. Once the command runs, we can see the modules enabled and the list of our targets. Now we have to wait until the victim visits the web page. After a few seconds, we can see the traffic intercepted, as well as the credentials sent. Although we use just a few options, you should know that BetterCap is very flexible and customizable. We suggest you use it while you perform man-in-the-middle attacks as it is constantly updated and serves numerous options. As you've seen, thanks to tools like EtterCap and BetterCap, running a man-in-the-middle attack is very easy. We suggest you try the attack in order to better understand how it works and what type of information we can gather by sniffing the network. Thanks for joining us.